Now the similar one, okay, from the transfer function. Now this is the transfer function. Now again same, okay, do the partial fractions a by s plus 2 plus b by plus c by, okay, same partial fractions, and these are the partial fractions values and the same procedure, okay. Now this is assume x1, this is x2, this is x3, like that you can move further, okay. But just a small indication here. Now you just locate the poles and zeros and explain here. Now there is a repeated poles at -2 and one pole is at -3, okay. So now I am not doing that long method. The long method is already doing in the diagonal form, okay. The same form you can do it, okay, same procedure, but I am giving the shortcut method directly. Just observe here. Now what is A matrix? x1, x2, x3 dot, okay. So this is 3 by 1, so automatically remaining all are, this is 3 by 3, this is the 3 by 3 matrix. Now this is x1, x2, x3. Now this is 3 by 1 plus, now this is 3 by 1 into u, because this u is only 1 by 1, okay. So what I want to say here is, so A matrix order is 3 by 3. So in the 3 by 3 matrix, how many number of poles are repeated? So the number of repeated poles are here 2. So when the number of repeated poles are 2, then you take a 2 by 2 matrix separate in a 3 by 3 matrix, okay. So in the 3 by 3 matrix, then you can take a separate part as a 2 by 2 matrix, because why sir, why 2 by 2 means, now number of repeated poles here is 2. So you should take again a 2 by 2 block in the 3 by 3 matrix. So which means that, now can I write like this? This is the 2 by 2 block. So before that, first you write the diagonals, okay. So what are the quotients? This is -2, -2, -3. Now it is easy, I think, I hope, okay. Now order is 3. When order is 3, therefore A matrix order is 3 by 3. So A matrix order is 3 by 3 because the number of state variables are 3. So this is the 3 by 3 matrix. In the 3 by 3 matrix, now first you write the closed loop poles in the diagonal, okay. After completion of the writing the closed loop poles in diagonal form, then again you take a separate block, now which will be the number of repeated poles. So the number of repeated poles are 2. So again you take a 2 by 2 block as separate. So 2 rows, 2 columns block is this, I hope. Right now, this is the 2 by 2 block. Then you ask, sir, which 2 by 2? Some of the students are asking that, sir, why you are taking this 2 by 2? You may take the bottom 2 by 2 also. Yes, that is also correct. So you should take a 2 by 2 matrix where the quotients must and should be the repeated poles. Okay, that block will be the repeated closed loop poles block. Therefore, see here, this is -2 closed loop pole. This is -2 closed loop. Now this is the repeated closed loop poles must and should be presented in the separate block what you are taking. Okay, so this is a 2 by 2 block. So this is the diagonal. Now in the 2 by 2 block, then this, the top of this element is 1, remaining all are zeros. 0, 0, 0, 0, 0, everything will be 0. Okay, so total 3 by 3. In that I just ask you to put the 2 by 2 matrix separately because the number of repeated poles are 2. Therefore the separate block order is 2 by 2. So in that diagonal, so in the 2 by 2 matrix diagonal element, then the top of that particular last diagonal element will be the 1 and remaining all are zeros. Now this is the boundary for the 2 by 2 matrix. Now in this boundary, this value is 1. Now top of the elements are zeros, bottom of the elements are 1. Okay, so this is matrix A, this is matrix B. Okay, this is matrix A, this is matrix B. Now you want a matrix C, so which is Y which is nothing but only 1 by 1. So this is 3 by this is 1 by 3 and this is x1, x2, x3, right? Now this is 3 by 1, 3 cancel 1 by 1, okay? So then what is the C matrix quotient? The C matrix quotient is a partial fraction quotient. What are the partial fraction quotients? The partial fraction quotients are 1, minus 1, 1. So 1, minus 1, 1. These are the partial fraction quotients. These are the partial fraction quotients. So if you have any confusion, sir, these values will give the correct or not, is there any doubt? Then I'm already saying that now if the transfer function is there, then how to do the procedure? Just know before this problem, then we will see the diagonal form. You follow the same procedure in the diagonal form and you can get this answer. Now see here. Now you just first identify where there is a repeated poles. Now that block you should identify. Now this is the block, okay? Now what I'm saying, the number of repeated poles are 2. Number of repeated poles are 2. Therefore, you should take separately a 2 by 2 block in the original matrices of A. So this block is called as Jordan block. This block is called as a Jordan block. Therefore, now this is called as Jordan representation. This is called as, this block is the Jordan block. Therefore, this type of representation is called as Jordan representation. This is a Jordan canonical form representation. Okay. Now this type of representation is called as Jordan canonical form representation. Now where is the Jordan block? This is the Jordan block. Okay. Note down. Okay. Now I hope you understand. Then you will try for this. Now y of s by u of s, which is nothing but 1 by s plus 3 whole square into s plus 2 into s plus 5. Okay. Now one pole is at minus 2 and three poles are at -3 and one pole is at minus. Now one pole is at -3, but at -3 the poles are repeat. Okay. Now you tell me, first of all, what is order? Order is 5, 3, 4, 5. Sorry, 2, 3, 4. So now order is 3, 4, 5. So the highest power in the denominator polynomial is 5. Therefore, order is 5 state variables. Okay. Now you can easily identify that is the 5 state variables, and A matrix order is 5 by 5. Now in that, then what is the Jordan block? Then the Jordan block order is 3 by 3. So total A matrix order is 5 by 5 because order is 5. Now in that, the Jordan block order is 3 by 3. Jordan block, right? We will see is correct or not. We will see. Okay. x1 dot, x2 dot, x3 dot, x4 dot, x5 dot. Now 5 by 1. Therefore, now this is nothing but, now first you write the elements -3, 0, -3, -3, -3. Okay. Now this is -3, -3, -3 and -4 and -5. Okay. Now first you write one thing you do. First you write the Jordan block such that it is easy for you. Okay. Now the Jordan block is nothing but 3 by 3 diagonal -3. Now this is -3. Okay. Now see here, whatever may be in the Jordan block, so the diagonal element top value must and should be 1. So this is the diagonal element in the Jordan block. Now this top element must be 1. Now this top element must be 1. Now this is the diagonal element. This is the diagonal values. The top of the diagonal element value will be 1 in the Jordan block. This is only in the Jordan block. Remaining all are zeros. Remaining all are zeros. Now, first you identify the Jordan block. So this is A matrix order is 5 by 5. In that the Jordan block is only 3 by 3. This is the Jordan block and this is the Jordan boundary. Okay. So in the Jordan block, whatever may be the diagonal element, the top of the diagonal element must be 1. Sir, but why you are not? Because there is no other row here. Top of this. This is the top of this one. This is the top of the element is 1. Okay. So then now this is only 1, 2. So now here you just see here. Now this is the boundary. The Jordan boundary is this. Now here these elements are 1. Now all the top of the elements are zeros and bottom of the elements are 1. This is the A matrix, this is B matrix, and what is the C matrix? The C matrix order is 1 by 5, and this C matrix is quotients is nothing but partial fractions. Whatever the partial fraction quotient, that will be the C matrix. Okay, clear or not? Now see here, once again I just repeat. So the transfer function order is 5. So A matrix order is 5 by 5. But in that the number of repeated closed loop poles are 3. Therefore the Jordan block order is 3 by 3. Now where is the Jordan block? This is the Jordan block. This is the Jordan block. Okay. So the Jordan block order is 3 by 3. In that, now first you write the repeated poles in the diagonal form. Repeated poles in the diagonal form in the Jordan block. Now where there is a diagonal element, the top of the diagonal element position should be 1. The top of the diagonal element value is 1. The top of the diagonal element value is 1. Remaining all are zeros. Okay. That is the Jordan block. And this is the Jordan boundary. The Jordan boundary value is 1. And top of all the ones are zeros and bottom of the ones are ones. Okay. Now this is A, B, and the C matrix quotients is nothing but partial fraction quotients. Okay. Now this form is called as Jordan canonical form. And that block is nothing but a Jordan block. This is a Jordan block. Okay. No. Okay, this is the Jordan canonical form of state space model. So you can easily identify when the Jordan block is coming. When there is a repeated closed loop poles in the trans function, then definitely you can get the Jordan block. Okay. So this is the story of the transfer function and differential equation, Jordan form, diagonal form, controllable form, observable form. Okay. Now I want to find the state space model from block diagram. From block diagram. Now he is giving block diagrams. From block diagrams, now I want to find the state space model. Block diagram is given, then we need to find the state space model. Now see here. Now when the block diagram is given, okay, then how to find the state space model we will see. The state space model is nothing but state equation and output equation. Now see here. Now this is one block diagram which is given to you. Now one block diagram is given. Now he is asking to find the state space model. The state space model is nothing but we want to find a state equation and output equation. Okay. Now see here. Now sir, then what is the procedure here? Now the procedure is first identify the number of integrator block. 1 by S is integrator, S is differentiator. This is one integrator block. This is another integrator block. Right. What is the step 1? Number of integrator blocks. Number of integrator 1 by S blocks. Number of integrator blocks. How many integrator blocks here? 1 and 2. So number of integrator blocks, will gives the number of state variables. Number of state variables. Number of integrator blocks will give the number of state variables. So how many integrator blocks here? 2 integrator blocks. Therefore 2 state variables x1, x2. Okay. So now see here. Before the integrator block, okay, before the integrator block, take the state variable. Before this integrator block, take the state variable in differential form. Then this is x1 dot. Why? Because this is the differentiation and you will go to integration block, differentiation integration cancel, and this is x1. Now this is x2 dot, differentiation and this integration is cancelled. Therefore this is x2. So before the integrator block, keep the state variable in differential form such that that differentiation integration is cancelled and you can get x1 and x2 at the output of the integrator block. Okay. So now what should you do? So x1 dot, I want x1 dot equal to something, right? So take only the incoming branches to the x1. x1 dash equation means take only the incoming branches towards the x1 dash. So if you want to write x2 dash equation, take the incoming branches only towards to the x2 dash, or take all the incoming path to the x2 dash, or take all the incoming path to the x1 dash. That should be the equation of x1 dash and x2 dash. So what is x1 dash? Who is coming to x1 dash? x1 is coming with a gain of minus 2 x1. Now who is coming to x1 dash? Now one person is coming. Now that person is nothing but u. Nothing is taking 1 into u. This is x1 dash. Now what is x2 dash? Same. Is there anybody is coming to x1 dash other than these two? No, that's it. Now x2 dash. Now who is coming to x2 dash home? So towards x2 dash. So x1 is coming here, right? This is nothing but addition, summer. Okay. Now x1. Now is there yes, x2 is coming. x2 is coming with a gain of minus 3 x2. And see here, from here somebody is coming here from here. Yes. Who is that? U. 1 into u. Now see here, this is x1 dash and this is x2 dash. That's it. Now same, similarly y. What is y? Now what is the incoming branches towards y? See here, from here one person is coming. x1. Here one person is coming, x2. That's it. Over. So you can easily write the matrices now. Am I not? Now what is A matrix? Tell me. Two state variables. A matrix order is 2 by 2, which is nothing but, what is the first row in A matrix? -2, and some of the students are writing -2 and 1 is wrong. This is U. A matrix is totally deals with the state variables x1, x2, x1, x2. First row x1, x2, x3. Second row x1, x2, x3, x1, x2, x3. How many are the state variables? That many you can extend. So x1 is there, -2. x2 is not there, 0. x1 is there, 1. x2 is there, -3. This is A. What is B? B is 2 by 1. So B matrix is, B is totally deals with U. U quotients are coming in B matrix. What is the U quotient? 1. What is the U quotient? 1. This is B. Now C matrix is nothing but a relation between output and state variable. So C is nothing but 1 by 2, which is nothing but 1, 1. That's it. Over. Okay, no doubt. Clear? This is the way you can easily write. Now any block diagram which is very easy to find the state space model. Now, whenever the block diagram is given, so you should follow the same procedure. That's what for every block diagram, signal flow graph, everywhere, transfer function, differential equation, I am giving the procedure. So you should follow the same procedure for a number of problems. If that kind of model is coming, then you strictly follow only one procedure. First you identify the state variables, then automatically the problem is almost solved. Now see here, this is another block diagram which is given to you. How many state variables? Because there are two integrator blocks. Number of integrator blocks will give the number of state variables. There are two integrator blocks here, therefore two state variables x1 and x2. And I am already saying that before the integrator block, put the state variable in differential form, x1 dash, this is x1, x2 dot, therefore this is x2. Same, only the incoming branches to x1 dash. What is x1 dash equation? Now the x1 dash equation is incoming branches to x1 dash. Therefore x1 dot equal to the incoming branches to x1 dot. So x1 is coming with -3 x1 plus 1 into u x2 dot. So what is x2 dot? Now this is x2 dot. Incoming branches to x2 dash. x2 is coming with -4 x2 plus 1 into u is coming 1 into u. Now y, what is y? Now y is nothing but this is x1 So x1 is coming to y, x2 is also coming to y with a quotient of 8x1 with a gain of 8x1 with a gain of 9. So A matrix order is 2 by 2. So what is the first row of A matrix and what is the second row of A matrix? Tell me now. -3, 0. Now 0, -4. Anything you observed? If the coefficients value in the diagonal, this form is called as diagonal form. This is a diagonal form. Okay. So this is a B matrix. Now B matrix coefficients are 1, 1. Okay. Don't fix that 1, 1. Okay. Whatever it will come, you will write that. Okay. C matrix is order is 1 by 2. So A and 9, 8 and 9. Okay. This is the ABC matrix. Now this is the state space model. Now this is the state equations and this is the output equation. This is the state equation and this is output equation. State space model consisting of state equation and output equation. Don't write the matrices form. Okay. You write the equations. Already options are available in the exam. Once the equations are available, based on that equation you pick up which of the following is the correct option. Okay. Okay. So if any block diagram is given, so first identify the number of integrator blocks and identify the number of state variables and write the state equation and output equation, state matrices A, B, C. Now we will find the state space model from signal flow graph. From signal flow graphs. Now, from the signal flow graph diagrams, then how to find the state space model? Now, we'll take one problem. Now this is the signal flow graph diagram which is given to you. Same. Identify the integrator blocks s power minus 1, s power 2 integrator blocks. Number of integrator blocks will use the number of state variables. So 2 integrator blocks, therefore 2 state variables. Now there is a summing point. Summer is available. So here the node will acting as a summing point. Now see here. Now before this integrator block, take the state variable in differential form x1 dot. So x1 dot and this integration differentiation is cancelled and here it is x1. But even again here is the integrator block. Now immediately it will start x2 dash. So we can do like this. So this is a common node. So x2 dot. Then we take a variable x1 and assign to x2 dot. Okay. We take a variable x1 and assign to x2 dash. We take a variable x1 and assign to x2 dash. So x1 assigned to x2 dash, x2 dash derivation and integration is cancelled and again this is x2. Enough. So take all the incoming branches towards that particular node. I want x1 dash equation. What is x1 dash equation? Tell me now. Now x1 dot is nothing but, now I want x1 dot is nothing but all the incoming branches to x1 dash. Okay, so minus 2 is coming with x1. Don't write x2 dash, is right? Wrong, because first derivative will be expressed only in terms of state vector and inputs. Okay, next x1 dash incoming branch is minus 9 x2 and incoming branch is u with 1. Next x2 dat. x2 dat is already available. x2 dat equal to x1. So A matrix first row is also available. What is A matrix first row? Minus 2, minus 9, 1, 0. Now B matrix is nothing but 1, 0. Now what is the Y equation? So Y, what is Y? Y is nothing but incoming branches. x2 is coming from in this path. Here, from in this path x1 is also coming. From in this path x1 is also coming. So Y equal to x1 plus x2. Some of the students are taking x2 dot. Wrong, because the output equation will be never dot. Output in terms of only state variables and inputs. So Y equal to x1 plus x2. Therefore, now the C matrix is 1, 1. This is matrix A, matrix B, matrix. Over. Not up. Clear or not? This is the way you can easily write the state equation and output equations. Now this is the state space model. In the GATE examination, this is important. He is not giving the model. You have to find the model. Okay. Once you can get the model, then next is just question and answers. Now this is the signal flow graph which is given to you. Now this is the signal flow graph which is given to you. Whatever may be a signal graph, you should follow the same procedure. Identify the number of integrator blocks. 1, 2, 3. Now total there are 3 integrator blocks. Now there are 3 integrator blocks, s power minus 1, s power minus 1, s power minus 1. Now the number of integrator blocks will give the number of state variables x1, x2, x3. Now take the state variable in differential form. X1 dot, this is x1. x2 dot, differentiation integration cancel, x2. x3 dot, differentiation integration is cancel, x3. Now take the state variable in differential form before the integrator block. So what is x1 dot? So here I will write, okay. Now what is x1 dot? x1 dot, which is equal to, who is coming to x1 dot? x1 is coming with minus alpha x1 and u is coming with 1 into u. Now what is x2 dot? Now who is coming to x2 dot? x2 is coming with beta minus beta x2. Now minus 2 into u. Now x3 dot, x3 is coming, sorry, let's assume gamma. So x3 dot, x3 is coming with minus gamma x3, u is coming 1 into u. Now this is x1 dot, x2 dot, x3 dot, okay. Now y, what is y? x1, x2, x3 is coming, 5x1 plus 6x2 plus 7x3. Now what is A matrix? Minus alpha 0, 0, 0, minus beta 0, 0, 0, minus gamma. What is B matrix? 1 minus 2, 1. Right? Now what is the C matrix? 5, 6, 7. This is A matrix, this is B matrix, this is C matrix. Note down.